Please sit down. On behalf of the Vice Chancellor, Professor Adebayo Simeon-Bamire, I welcome all of us to the 386th Inaugural Lecture to be delivered by Professor EMMANUEL ARIYIBI. Professor EMMANUEL ARIYIBI obtained his BSc and MSc degrees in physics from Obafemi, Awolowo University, Ile-Ife, Nigeria, respectively in 1991 and 1998. He also obtained a postgraduate diploma in computer science from the University of Lagos in 1996. His MSc research is in the area of geomagnetism, magnetotelluric, while his PhD work is in the area of explorative geophysics, carried out at the Federal University of Technology, Akure, Nigeria, and completed in 2008. He joined the services of the Department of Physics, Obafemi Awolowo University in 1995 as a graduate assistant and rose to become a full professor in 2015. He was head of department from 2019 to 2022. Currently, he is the head of Earth and Space Physics Research Laboratory of the Department of Physics and Engineering Physics, Obafemi Awolowo University, Ile-Ife, Nigeria, with research topics covering the areas of Ionospheric physics, geomagnetism, and applied geophysics. He has successfully supervised 4 PhD, 13 MSc theses, and more than 30 BSc project dissertations. He had 1 year sabbatical leave at the Department of Physics, University of Lagos, Nigeria, during the 2012-2013 session. He was a regular associate of the Abdul Salam International Center for Theoretical Physics, Trieste, in Italy, between 2004 and 2011, and currently is an associate of the Committee on Space Research in Paris, France, from 2004 to date. He had won many travel grants, fellowships to attend international conferences and workshops in Italy, Romania, Botswana, South Africa, Austria, and so on. Currently, he is the president of Ile-Ife Central Camp of Gideon's International in Nigeria. Professor ARIYIBI is a reviewer of many reputable journals within and outside Nigeria, including the Arabian Journal of Geosciences, that's a Springer publication, Ife Journal of Science, International Journal of Hydrology, Science and Technology, NRIAG Journal of Astronomy and Geophysics, Elsevier publication, Modeling Earth Systems and Environment, Springer publication, Natural Resources Research, Springer publication, Advances in Space Research, that's Elsevier publication. Professor ARIYIBI is a member of many professional bodies, including memberships of American Geophysical Union, Institute of Physics, London, International Association of Geophysics and Aeronomy, Nigerian Institute of Physics, Working Group on Space Science in Africa, Institute of Navigation, USA. Recently, Professor ARIYIBI was inducted a fellow of the Nigerian Institute of Physics. As Senate member of the university, Professor ARIYIBI represented Senate in the University Press Council between 2019 and 2021. He was also a member, governing board of Center for Energy Research and Development, OAU, Ile-Ife, between 2019 and 2022. He is also a member, joint board of Engineering Physics Program with Center for Energy Research and Development, OAU, between 2019 and 2022. So I present to you Professor ARIYIBI that will be presenting the inaugural lecture titled Exploring Health and Space for the Benefit of Mankind. Thank you very much.
Distinguished members of Senate, provosts, deans, directors, heads of departments and units, staffs of the university, highly esteemed colleagues, invited guests, family members, friends, grateful students, gentlemen of the press, distinguished ladies and gentlemen. All glory to the Almighty God for making it possible for me to stand before you today to give this 386th inaugural lecture of the Obafemi Awolowo University, Ile-Ife, Nigeria, titled Exploring Earth and Space for the Benefit of Mankind. This is the 10th inaugural lecture series coming from our department, Mankind and Human Race. According to biblical account in the book of Genesis chapter 1, God decreed and created the heavens, space, and the earth. In the same book and chapter, in verse 26, man was created in the likeness of God. God blessed man and desired that he should subdue and have dominion over all the earth and the space that extends from it. According to Anthony Robbins and Abraham Maslow, both of whom are psychologists, they identify and itemize the needs for the physical and spiritual survival of man. From Joe's scientific perspective, some of man's needs can be obtained from scientific exploration and the exploitation of the resources available on the earth and in the space environment for his benefit. The basic needs of man include food, clothing, and shelter. Over many centuries and civilization, the need of man have grown to include being able to communicate, security, safety, and ability to monitor his environment to mitigate against probable natural or anthropogenic disaster, which may directly or indirectly result from extraneous factors. My early days. According to available records, I was born in Mushin, Lagos on the very last day of 1968 to late Pastor Samuel Olusoya and Halaja Salimot ARIYIBI, both from Abeokuta, Ogun State. I had my primary education both at Ahmadiyya and Waru Islam Primary School, beside Guinness PLC of Accra and Ikeja, Lagos, 1974 to 78. And at Shiloh Primary School, Kekoto Agege, Lagos, 1978 to 80. My secondary education was at Vetland Grammar School, Agege, Lagos, from 1980 to 1985. I was admitted to Obafemi Awolowo University, Ile-Ife, in 1987 to study physics. My academic experience during 4 years for the undergraduate degrees was very exciting, with good and experienced scholars that impacted in me knowledge that shaped my life for good. Worthy of mention are the lives of Professor J. Oyedele, late Professor O. Odunu, Professor J. B. Aladikomo, Professor G. C. Oyedim, Professor O. Alabi, Professor J. B. Arubai, Professor E. Balogun, late Professor S. Ogunade, Professor F. Oluwole, late Professor F. A. N. Osadebe, and so on. These senior academics showed and demonstrated dedication, diligence, and commitment, which serve as inspiration for me, among other reasons, to decide to have a career in academics. After graduating in 1991, I returned during the 1993-94 session for my MSc program under the supervision of Professor Ogunade. For my MSc research, we, that is myself, Professor Ogunade, Professor Onyedi, and Dr. Christoph Peter of the Institute for Geophysics, Göttingen, Germany, went on a field work in February 1995 around Benue Trough, establishing data stations at Lafia, Makurdi, and Otukpo, using the state-of-the-art magnetoloric equipment. This was provided under a funding arrangement made possible by Volkswagen of Nigeria. After the fieldwork experience and good performance in my MSc coursework, my supervisor recommended me to the Department for Employment as a graduate assistant. Hence, I assumed duty on 5th June 1995. My MSc research was titled Magnetoloric Studies of the Middle Benue Trough. I successfully defended the thesis in November of 1998. With the demise of Professor Ogade in 2001, I registered for a PhD in geophysics at the Federal University of Technology, Akure. I completed the program in 2008 with research focus titled Geophysical Investigation for the Delineation of Potential Mineralized Zones in southern part of Elisha area, southwestern Nigeria. The project was jointly supervised by Professor S.L. Folami, Professor B.D. Ako, and later Professor J.S. Ojo. Worthy of note is Professor Olorunfemi. I'm sure he's well seated here, a renowned geophysicist of the Department of Geology here at OU, who started as my academic critic, especially during my PhD program while on a sabbatical at FUTA. However, he ended up as my academic mentor and father. At various occasions, he's always there to instruct and defend me to attain academic excellence. The electromagnetic waves. The discoveries and formulation of the principle of EM waves by the combined effort of Andre Murray, Ampere, Michael Faraday, James Clerk, Maxwell, among others, provided a good understanding of this phenomenon. However, it is the interaction of EM waves with substances or matter that is relevant and readily find applications in the field of medicine, material science, geoscience, astronomy, and so on. The EM spectrum, which covers from microwave to gamma ray wavelength, provides scientific opportunity to probe and characterize various material media. Hence, Mr. Vice Chancellor, sir, we rely on the earth for valuable resources such as soil, water, metals, industrial minerals, and energy. And we need to know how to explore and exploit these resources sustainably. Equally, we can use our knowledge of the earth to understand other planets in our solar system, as well as those around distant stars. The simple answer to the questions above is that the earth is our home, our only home for the foreseeable future. And in order to ensure that it continues to be a great place to live, we need to understand it. Additionally, there's more to it than that. We can study rocks and the forces they contain to understand the evolution of our environment and the life within it. We can understand how to mitigate our risk from earthquakes, volcanoes, slow failures, and damaging storms, including rainstorms and geostorms. We can use our knowledge of Earth to understand other planets in our solar system, as well as those around distant stars. We are all explorers. Man by nature tries to explore his immediate environment for reasons that may be for economic and even for survival purposes. That explains why in medieval times, Amerigo Vespucci discovered the New World, North and South America, which were later populated by migrants in large numbers, more than the original owners. Similar instincts in man is also responsible for space exploration. Exploring space is an opportunity not only to discover new worlds and build advanced technologies, but also to work together towards a larger goal, irrespective of nationality, race, or gender. If we stop exploring, we stop being human. Studying the solar system, for example, has brought us insight into such phenomena as gravity, the magnetosphere, the atmosphere, fluid dynamics, and the geological evolution of other planets. About 120 years ago, the world population is less than 2 billion. And currently, we now have over 8 billion humans on Earth. This population figure was attained with no corresponding increase in Earth landmass. The need to find other areas of the Earth and other planets habitable to man is very important to lessen the conflict over economic and political agitations for land utilization. Colonizing other bodies in the solar system or building our own orbiting habitat is a way to create a backup of humanity that will survive no matter what happens to Earth, including a possible nuclear war conflagration. Maybe future humans will be Martians who will never set foot on Earth. Commercial spaceflight, currently operated by SpaceX of Elon Musk, is already providing passengers with the experience of life for some periods outside of our Earth, just like astronauts who are regularly on board the ISS station. My research effort. With good training and knowledge in geomagnetism and applied geophysics and a PG diploma in computer science, I'm well prepared to explore the Earth and the space environment. However, self-development was also necessary for me to advance in the academic profession. The fact that the geomagnetic field, some from the cluster field, main field, and secondary field, stimulated my interest in space studies, especially to study the variations arising from external field sources. My first set of papers were review articles on solar activity and the occurrence of magnetic storm and its disruptive effects, alongside the article on magnetological studies on the Middle Trough. These initial efforts were very helpful as it provided me an opportunity to get research sponsorship and travel grant fellowship to Romania, South Africa, and Italy. The geomagnetic field. The Earth is like a magnetic dipole, as we can see in that figure, similar to the Earth field. The geomagnetic field extends from the Earth's inner core to where it meets the solar wind, a stream of energetic particles emanating from the sun. The geomagnetic field is used to explore the dynamics of the Earth's interior and its surrounding space environment in what we call the space weather. And geomagnetic data are used for geophysical mapping, mineral exploration, risk mitigation, navigation, and other practical applications. The geomagnetic storm, or a storm, is a major disturbance of the Earth's magnetosphere that occurs where there is a very efficient exchange of energy from the solar wind into the space environment surrounding the Earth. This storm results from variation in the solar wind that produces major changes in the current, plasma, and the field in Earth's magnetosphere. And of course, during storm, the current in the ionosphere, as well as the energetic particles that precipitate into the ionosphere, add energy in the form of heat that can increase the density and distribution of density in the upper atmosphere, causing extra drag on satellites in low Earth orbits. And of course, we have what we call geomagnetic index. A geomagnetic storm is defined by the changes in the DST, or what we call the stop time index. The DST index estimates the globally average change of the horizontal component of the Earth's magnetic field at the magnetic equator based on measurement from a few magnetometer stations. And of course, it is computed once per hour and reported in near real time. Other index of interest is the KP index, AP index, AE index, sunspot numbers, and solar radio flux. And of course, we have many geomagnetic storm effects that readily comes to mind. And of course, one we want to report that just last August, there was a magnetic storm of high magnitude, actually, last August. So it will be of interest for research, actually. So I'll just mention some of them briefly, the effects that are highly, that can be observed. In communication, high-frequency communication systems use the ionosphere to reflect radio signals over long distances. Ionospheric storms can affect radio communication at all latitudes. Some frequencies are absorbed and others are reflected, leading to rapidly fluctuating signals and unexpected propagation paths. Radio operators during the storm using HF band rely upon solar and geomagnetic alert to keep their communication circuit up and running. And of course, we know that GNSS in the area of navigation system and others are adversely affected when solar activity disrupts their signal propagation. Airplanes and ships that relies on GNSS use the very low frequency signals from this transmitter to determine their position. During solar events and geomagnetic storm, the system can give navigators inaccurate information of their position by as much as several miles. The navigators can, however, shift to backup autonomous system if there was an alert that a geostorm is in progress. And of course, in the area of geophysical survey, Earth's magnetic field is used by geophysicists to determine subsurface rock structures. This is possible only when the Earth's field is quiet, so that true magnetic signatures can be detected. For these reasons, many surveyors themselves use geomagnetic alert and prediction to schedule mapping activities. In the area of pipelines also, rapidly fluctuating geomagnetic field can produce geomagnetically induced currents in pipelines. This can lead to many leakage points. Also, the effect on animals. Some scientists in the area of geomagnetobiology have speculated that migrating animals, which use magnetoreception to navigate, such as birds, fish, and honeybees, might also be affected during such a storm. ICTP Fellowship, Earth and Space Physics Research. I have so far presented the importance of geomagnetic field and the possible effects its variation may have on physical and biological systems. A review paper documented in ARIYIBI et al. 2003 AB, ARIYIBI et al. 2004 were the main papers that define my academic career. With these papers and others, I was able to win a travel grant to University of KwaZulu-Natal, South Africa in 2004, and also won the prestigious regular associateship of the Abdulsalam International Center for Theoretical Physics, Trieste, Italy, 2004 to 2011. With the assistance of ICTP and Boston College USA, our laboratory was provided with the Novatel GPS model in 2009, as you can see in figure 2. This facility, together with the available proton precision magnetometer, form the nucleus of equipment available for the Earth and Space Physics Research Laboratory, postgraduate students' supervision, Earth and Space Physics Research Laboratory. Thanks to the postgraduate college and the PG committee of my department that provided me with very good and brilliant students who were able to share my academic vision, mission, and aspiration in the field of Earth and Space Physics. I have a privilege of having about 10 master students and 4 PhD students under my supervision during the period of 2010 and 2017. With them, the ESPRL became very active and vibrant, and we jointly published research articles in many reputable journals. I wish to briefly present some of these research results, which are of immense benefit to mankind in many respects. Earth and Space Physics Research at ESPRL benefit to mankind. Mr. Vice Chancellor, sir, the first area of our focus is in the area of groundwater. As we all know, water is one of the most important natural resources which man cannot do without. Groundwater is the water occupying the spaces between rocks and in the tiny interconnected spaces between individual grains in rocks. It is free from suspended matter and bacteria. It can be said to be pure, clear, and colorless. It has greater quality than surface water, and so useful for domestic and industrial purposes. Public water supply is not readily available in most urban, semi-urban cities of Nigeria. Hence, individuals, local authorities, or donor agencies resort to drilling of boreholes for groundwater to meet the water needs of the people. However, groundwater development in the crystalline basement complex areas is problematic and is characterized by a spate of failures of boreholes arising from poor understanding of the basement complex hydrologic setting. My graduate student, Awoshika Ethod, jointly with me in 2020, we carried out the evaluation of groundwater potential zones using integrated geophysical approach in Obuewi, Ondo East local government, southwestern Nigeria. And this area actually suffers from a shortage of fresh water, and the main source of water is rainwater. Groundwater provides an alternative solution to face the gap between water demand and available water in this area. And this study, from our study, we're able to establish that the groundwater potential map revealed that about 69.6% of the study area fell within the poor groundwater potential rating. About 21.7% constituted the moderate groundwater potential rating, while the remaining 8.7% constituted high groundwater potential rating. The study actually concluded that the groundwater potential of Obuewi, Ondo Town, is generally poor, with areas around central south and far northern part of the study area having good groundwater potential, suitable for siting of boreholes. In other words, by my graduate students, Dasho et al. 2017, we jointly carry out satellite remote sensing to groundwater potential modeling in Ejigbo area, southwestern Nigeria, using Landsat 7 EMT Plus and NASA GDM image of Ejigbo area, Osun State, Nigeria. And the study actually concluded that the groundwater potential of areas around Ejigbo, Osun State, is of poor to moderate level rating. There are, however, very few areas with good to very good groundwater potential. In yet another regional work, also with my graduate students, Dasho et al. 2021, we carry out a tracking of total water storage over river basins over Nigeria using great satellite so that we can have a wider coverage. And of course, in that work, the work concludes that the increase in total water storage in most of the basins is likely due to change in groundwater recharge qualities, and therefore suggests that increasing access to improved groundwater sources is likely to be highly successful in mitigating the adverse effect of climate change in sub-Saharan Africa. Mr. Vice Chancellor, sir. We also look at waste management. Indiscriminate disposal of domestic and industrial waste not only have adverse effect on the environment, but also can create a breeding ground for diseases waste disposal and sanitation habits in sub-Saharan Africa, Nigeria inclusive, have not been encouraging. Lack of established waste disposal sites have compelled people to dump waste in open spaces, marketplaces, on sidewalks, and even in streams, thereby turning such places to breeding ground for vectors of typhoid fever, cholera, and other infectious diseases, particularly as it affects the degradation of natural groundwater quality. In the work by my graduate student Adebayo et al. 2014, we jointly carried out an environmental assessment of all domestic dump sites using 2D electrical resistivity imaging, a case study over Olubokun dump site, Osun State, in Ede. And of course, the 2D resistivity structure showed that the topsoil has virtually merged with the weathered layer because of overlapping relatively low resistivity values, which is less than 10 ohm meters, with a depth range of 1 to greater than 5 meters for topsoil and weathered layer, which were suspected to be due to high metal content and thus leachate saturation, as you can see in figure 4. It was also observed that the weathered layer constitutes the aquifer unit in the study area due to the observed relatively shallow water table of about 2.1 to 3.5 meters around the dump site. The groundwater around the dump site is suspected to have been polluted. Also, in another work by my graduate student at Adebayo et al. 2015, we also tried to delineate contamination plumes over the same site using geophysical and geochemical approach. The elemental concentration of potassium, calcium, manganese, zinc, nickel, copper, chromium, and iron in the soil sample located in the periphery of the dump site are much higher than those of the control sample point, indicating pollution, while water quality analysis from existing hand-dug wells show increase in concentration of nitrate exceeding permissible WHO limits. It was therefore concluded that the soil and the groundwater in the vicinity of the investigated dump site had been polluted. In another work by my graduate student Olagoje et al. 2017, we also carried out a geochemical geophysical approach to environmental impact assessment, a case study over a marine active open dump site in Ado-Ekiti. The 2D resistivity structure shows migration of leachate to a depth of 0.5 to 12.5 meter along traverse 3 and 1 to 25 meter along traverse 1, 2, and 4 in the study. These deductions are actually corroborated by the geoelectric section with the correspondingly low weather layer resistivity values of 11 to 37 ohm meters and thickness ranges of 4.8 to 8.7 meters beneath the dump site. It was also concluded that the groundwater, river, and soil within the vicinity of the investigated dump site have been contaminated to an estimated extent of about 25 meters, and leachate flow along the southwestern direction of the waste site. Mr. Vice Chancellor, sir, we also look in the area of mineralization. Nigeria is actually endowed with vast but largely untapped solid minerals, resources especially for maximum economic advantage. These minerals include tin ores, iron ore, clay, talc, lithium, among others. Particularly, the schist belt region of Elisha and northwest Nigeria are known to be mineralized, especially with the existence of sulfide minerals such as gold and other precious stones. However, the occurrence of these minerals are structurally controlled and require geoscientific investigation to determine their economic viability for their exploitation. ARIYIBI in 2011 actually carried out a geophysical study around Elisha area within the schist belt of southwestern Nigeria, aimed at delineating the mineralization potential. The geophysical methods engaged actually help to map the structural complexity, such as evidence of faulting, mineralized fracture, joint and dikes in the study area. In addition, it is now evident that mineralization is not limited to within the amphibolite, but also exists in other rock types. Additionally, there's an improved delineation of the rock contact, which has hitherto been difficult to map as a result of death of outcrops and the presence of overburden. Furthermore, ARIYIBI et al. 2011 actually applied a multivariate technique, the principal component analysis on geochemical data, a case study over the basement in southern Elisha area. The studies aim at identifying the potential source of mineralization dealt with before in regional studies. And of course, the analysis identified the metallic association of iron manganese, lead chromium, and cadmium zinc within the amphibolite, schist, and epidermal complex, causite and core schist. In another work by my graduate students, Adegoke et al. 2021, we jointly carried out a geophysical interpretation of magnetic data over mineralized zones of Itagumode, southwestern Nigeria. This was with a view to provide information on the depth of basement rocks, the subsurface geologic layers, and essentially how these geologic structures serve as indicators for the occurrence of minerals and also its possible contribution and influence to the deposition and disposition of minerals in the Itagbode town. The study actually concluded that the mineralization in the Itagbode area is structurally controlled. Mr. Vice Chancellor, sir. We also look at in the area of regional geologic structures, which have significance to many things. According to Wright 1968, over Nigeria and part of West Africa, the formation of the regional main geological structures resulted from the intercratonic rift in which the release of torsional threads is associated with the separation of Africa from South America. These major structures are of significance to understand the subsurface geologic settings of the country and should also guide in the construction of critical infrastructure such as dams, interstate roads, bridges, and so on. ARIYIBI et al. 2004 actually used the MT survey, magnetologic survey, around the Benue Trough with data acquired simultaneously from Lafia, Makurdi, and Otukpo. The orientation of the induction vectors at Makurdi and Lafia confirmed the existence of fault and shear zones at the flanks of the trough. And this probably coincides with the chain and the Charcot lineaments. The study also revealed the presence of narrow fault zones within the trough, as shown by the induction vectors at Otukpo at all the periods. The empty data from the three cells in the Middle Benue Trough have been interpreted in terms of a 1D model of the subsurface structure. The empty model indicates the presence of conducting crustal structure in the Middle Benue Trough. ARIYIBI et al. Also, 2003, also presented geomagnetic intuition vectors at sites located near the coast, basement, and the Middle Benue Trough, covering essentially part of the southwest and the Middle Benue Trough. That actually was a review paper jointly with the 2004 paper. And the results show that coastal effect was evidence as the magnitude of induction vectors for night events at Ikorodu, Awa, Igbado, and Okitipupa were larger when compared to the basement sites. Since only night events were considered, the influence of the equatorial electrojet was not responsible for the enhancement of the induction vectors. And of course, the orientation of the induction vectors, especially in the basement side, indicate more the existence of inland anomaly, which are oriented roughly in the east-west direction, rather than the inferred extension of the oceanic fractures into the continent. The probable extension, continental extension of the mid-Atlantic oceanic fractures, the St. Paul, Romanche, Chain, and Charcot, adapted from Ajakaye, 1986-87, is as shown in figure 6, slide 10. The induction vector at the coastal side indicated coastal magnetic anomaly, which are due likely to the mid-Atlantic fracture zones. Also, the induction vectors at the Middle Benue Trough indicated 4 zones, both within and the boundaries of the trough. And of course, another work by Awolowo et al., also in our group, examined the aeromagnetic imaging of the basement morphology in part of the Middle Benue Trough, Nigeria. And the study actually gave important, as these basement features are vital structure due to evolution of the trough in general, serve as indication of suitable structural target in the exploration for groundwater, solid minerals, and oil in the area investigated. Other regional structures of geologic significance identified were as elucidated in Awoyemi et al. 2005-2016 on basement fault propagation in the Chad Basin of Nigeria, which shows that the sedimentary section was affected by the tectonics of the underlying basement, with faults propagating from the basement upward into the sedimentary cover. These faults constitute potential structural trap for oil accumulation or conduit for oil migration. Mr. Vice Chancellor, sir. Our study also involved in the area of building and infrastructural development. There has been reported cases of roads, bridges, and building failures, which are traceable to lack of adequate geologic information about the overburden thickness and its competencies to support the structural loads. My graduate student Adedika et al. We jointly carry out a geological survey along Ibadan-Ife highway around Akinolu, Ekwetumedu, located in the Precambrian basement complex of southwestern Nigeria, to examine the geological factors responsible for this highway pavement failure in that area. It's a well-known area. And of course, in that study, the fair portion of the road are probably precipitated by thick and low resistive substratum, which is clay, beneath the highway pavement, and the identified suspected linear features are the major geological factors responsible for the highway pavement failure. Thick and low resistive substratum which has a resistivity between less than 100 whole meter, clay subgrade soil. The soil type absorbs water, swell, and collapses under imposed traffic load, low stress, and thereby leading to road pavement failure. In another work by my graduate student, Dashu et al. 2020, we carried out a seismotectonic analysis of part of Togo, Benin, Nigerian shield by delineating and characterizing cluster discontinuity using gravity Bogian anomaly data. This was with a view to understand the significance of the discontinuity of the seismicity of the area. And of course, the prominent north-south trend pattern aligned with the general north-south foliation stripe emplacement across the shield. The Lagos-Ibadan Jebu-Ode fault line was identified in this map as having close proximity to locations of previous earth tremors and therefore might be associated to those events. Heliophysical studies at low latitude to improve IRI model. Heliophysics involves the study of the sun and its effect on the earth and other bodies within the solar system. It is concerned with the magnetosphere, ionosphere, thermosphere, mesosphere of the earth and other planets. The ionosphere is a shell of electrons and electrically charged atoms and molecules that surrounds the earth between 80 and about 600 kilometers, where UV and X-ray solar radiation ionizes the atoms and molecules, thus creating a layer of electrons. The ionosphere is important because it reflects and modifies radio waves used for communication and navigation. Also, large geomagnetic storms triggered by solar flares and coronal mass ejection from the sun can create severe temporary disruption in the ionosphere. As you can see, the ionosphere is very close to the earth in that figure 7. The IRI is the internationally accepted standard of the ionosphere and is officially certified by as such by the ISO. The IRI model is continually upgraded as new data and new modeling approaches become available. And this process has resulted in several major milestones edition of IRI. The result, which will also serve as input to improve the IRI model, adaptable to low latitude ionosphere location in Africa, a region where there is paucity of data and the occurrence of complex phenomena such as the equatorial electrojet. My graduate student Akitu Fede et al. In 2016 actually carried out a total electron content variation during geomagnetic activities in Ile-Ife. Comparative results between GPS and IRI tech show similar patterns of diurnal variation. The result of the research revealed the need for adjustment in the IRI 2012 for better representation of low latitude ionosphere, more especially over Ile-Ife, Nigeria. Another work by my graduate student Olatubosun et al. 2019 observed discrepancies in IRI model prediction at at Nigeria low latitude station. And in that work, day-to-day, monthly, seasonal, and annual variation of tech were observed, with IRI predictions values consistently higher than the GPS measured tech values at all segments, especially during the day-time plateau and the K region. The relative deviation of measured tech from the model tech showed appreciable differences, about 70% in most cases. IRI 2016 therefore overestimates the GPS-derived tech at low latitude station. Another fairly recent work by Awolowo and ARIYIBI 2010 actually examined the geomagnetic storm main phase effect on equatorial ionosphere over Ile-Ife as measured from GPS observation. And in that work, we were able to observe maximum tech values of 55.8 tech was recorded during the main phase of the September 26, 2011 storm event, depicting tech enhancement. Significant scintillation index value of 0.57 was observed when the main phase started on August 6, 2011, followed by a prolonged suppression, while there was less significant scintillation impact on September 26, 2011, with a maximum value of 0.33. The study showed rapid energy input from solar wind during geomagnetic storm event and effect large variation in tech and significant scintillation phenomenon in the equatorial ionosphere over Ile-Ife, Nigeria. Then another work on ionospheric studies at low latitude, we want to look at its implication for navigation and communication. Magnetic storm is a recurring phenomenon and is established to have a relationship with the solar cycle. The induced current during such storm have tremendous impact on life on the planet Earth. In order to guide against economic and other losses that may result from poor navigation and the possible disruption in signals, data, messages, and utility supply, it is very necessary to have geomagnetic observatory that can supply accurate data in near real time to issue alert when magnetic storms or disturbances are likely to occur. And so big corporations such as telcos, power, oil companies, among others, can benefit from such data. In a work by ARIYIBI et al. 2003 that work on the variation of solar activity and the occurrence of geomagnetic storm, the solar activity as measured by sunspot number predicts an 11-year solar cycle for the number of sunspots to be maximum. It was established that few years after the maximum, high magnetic activity, that is magnetic storm occurrence, arises. And during a geostorm, which is a global phenomenon, elements of geomagnetic field are affected, and the rapid field changes induce electric currents called geomagnetically induced current into space, atmosphere, and the earth's surface. In other work, ARIYIBI et al. 2013, using the dual frequency GPS receiver at Ile-Ife. The vertical tech in this study showed that the value varies widely from as low as 0 TEC to about sunrise to about 35 TEC during the day. Depletion in TEC was also noticed about sunset and marked by the occurrence of scintillation with a maximum index value of 0.3. Result of the IRI model and the observed tech differs considerably. Hence, the need to improve IRI model for its adaptability to the African ionospheric condition. ARIYIBI et al. 2013b also carried out a study of ionospheric variation during geomagnetic storm at a low latitude station using the GPS receiver at Ile-Ife. From the interpreted data, the occurrence of geostorm does not necessarily suggest an increase in the level of scintillation at a low latitude region. Also, there is a remarkable difference between the RI 2007 model and the observed tech values, as the daytime tech peak differs in magnitude and time of occurrence from the observed tech. ARIYIBI again 2014 also worked on the estimation of ionospheric slab thickness during the period of low geomagnetic activities at a low latitude station. Generally, we know that the estimated slab thickness range between 240 and 340 kilometers, attaining a maximum value during 12 local time and 14 local time. Also, the diurnal and seasonal variation clearly validated the linear relationship existing between the tech and the slab thickness over the African ionosphere. However, the equinoctial season was exceptional, as an abnormal rise in slab thickness value reaching 2,800 kilometers between the hours of 14 and 18 hours local time was observed. This abrupt change in slab thickness of the ionosphere was probably due to the intensification by the solar wind magnetosphere coupling. Additionally, ARIYIBI 2014 also examined NMF2 and TEC of the equatorial ionosphere during the period of geomagnetic storm, as observed from the GPS data in Ile-Ife. The results show that for a geomagnetic storm of comparable order of magnitude in DST and KP, the maximum electron density and tech values varied markedly. In another work by my graduate student Jimo et al. 2016, we jointly investigated the ionospheric response to two intense geomagnetic storms of 9 March and 1st October 2012 over a low latitude station in Ile-Ife, Nigeria. And of course, we know that the change in ionospheric delay, which is proportional to change in TEC during geomagnetic storm, is a potential limitation in precise positioning using radio waves from GPS, hence have an adverse effect on navigation and communication system. In another work by Olatubosun et al. 2020, we examined the HF propagation during geomagnetic storm at a low latitude station over Guam. Guam is also on the same EEG, just like Nigeria. And of course, comparative study between the ionogram of disturbed and undisturbed ionosphere showed that geomagnetic storm led to increase of F0, F2, MUF values, and MF2 values. The results also revealed that the strength of the refracted signals were particularly good, strong enough to rebound from the earth and refract again. In another work by my graduate students again, Olatubosun et al. 2017, we investigated the occurrence of scintillation during the intense geomagnetic storm at low latitude station with a view to knowing the contribution of geomagnetic storm on scintillation occurrence. The GPS receiver can then be designed to operate in scintillating environment. Comparative result between scintillation occurrence during storm and that during quiet time showed that scintillation was more pronounced during quiet period over all stations. Another work by my graduate students Awolowo et al. 2019 also considered diurnal and seasonal variation of equivalent slab thickness over low and mid latitude station, over St. Louis, which is Brazil, and Chilton, which is in UK. And of course, the monthly variation also indicates and lowest below 300 kilometers during summer months for the low latitude station of Sao Luis. However, the nighttime values are of the same order, which is about 200 kilometers for the low latitude station over Sao Luis. Also, highest daytime values above 250 kilometers are also observed during the summer months, and the nighttime values are below 200 kilometers over the years for the mid-latitude station of Chiltern in the UK. Mr. Vice Chancellor, sir, we also try to look at the deep space, that is deeper into space. What do we see? The term outer space refers to anything beyond the Earth, including things very close to home in low Earth orbit, which begins as low as 160 kilometers above the planet. This space, on the other hand, starts a bit further out. It is often considered to be anything further away from the Earth than other moon, and can refer to things beyond our solar system entirely. As you can see in that plate 1, our Earth and solar system is in that plate. Our Earth and solar system is in that plate. The objective of our studies of this space can help to unravel, 1, if there are other life elsewhere, we want to know. 2, if there are habitable planets out there for humans. And 3, if there are other resources out there that can be helpful here on Earth. Earth is just infinitesimal in that plate. We must know that our present study may not be able to locate the paradise or heaven or hell in a religious sense. I mean, as this may only be visible in a spiritual sense and not available on the EM spectrum. ARIYIBI in 2009 actually presented a preliminary observation of the Chandra data in order to study the pulsar wind nebula in the supernova remnant I-6443. The observed density numbers and the normalized counts of both the point source and the diffuse source were used to describe the X-ray source. And of course, the fact that the ejector that comes out from that source never comes out smoothly revealed that the shape of the X-ray point source is not uniform, and also it undergoes non-rigid body rotation. ARIYIBI in 2016 also investigated simultaneous multi-satellite observation over the solar quiet wind condition and the energy rate estimation of the associated current using magnetic data from the interball tail and geotail satellites, which are some distance away from the sun, so farther from our Earth. The result from this work showed that more magnetic energy is available at the magnetotail. This magnetic energy is part of the energy responsible for driving the plasma flow, eddy currents, and plasma instabilities. After magnetic reconnection at the dust side of the moon midnight meridian plane, such energy rate can be more during a magnetic storm and the often associated substorms. In another paper, ARIYIBI 2016 on the quiet solar wind condition with magnetic data from the wind and geotail satellites, which are at apogee of 240 radius of the Earth, respectively, were considered for the already identified quiet solar wind condition, which extend from 8 March to 10 March 1997. From the magnetic record on the satellite and the corresponding measurement from a ground-based magnetometer at the southern pole, it was established that during period of solar quiet variation, the horizontal component of the field are responsible for the observed current cell on the sunlit southern hemisphere, which goes clockwise. Conclusions and recommendations. Mr. Vice Chancellor, sir. From the foregoing, our research experience have afforded us the knowledge of the interior of the Earth to identify geologic structures suitable for the occurrence of groundwater, is mineralization, and the existence of linear features which have great implications on critical infrastructural development. Our research efforts have also provided valuable data and interpretation for the complex nature of the Earth's ionosphere, particularly over Africa, where there is paucity of data and where there is a dominant effect of EEJ. Quality and potable water is very essential to man. This ordinarily should have been suitably provided by public water works to cater adequately for the water needs of the populace in our semi-urban, urban towns and cities. However, the failures on the part of government to provide these basic needs in most parts of Africa, Nigeria inclusive, have made non-governmental organizations, individuals, and even some government agencies to embark on sinking of boreholes to ameliorate inadequate water supply, or outrightly serve as alternative to public water supply in many of our communities and individual homes. The number of boreholes that will be sunk to cater for the greater part of a nation or state water needs will in no doubt have aggregate adverse effect on the stability, equilibrium of the Earth's surface. Therefore, it is very important that provision of water by public water works should be mandatory, encouraged, sustained, modernized, and properly networked to reach all our communities. In most cases, dump sites are originally located on the outskirts of towns. However, the increase in rural-urban population migration, coupled with limited land availability, makes the SY land on the outskirts of town to become residential areas. This is the case with Oluboku and Emery dump sites, which were cited earlier. Additionally, the amount of waste generated is ever increasing and often disposed inappropriately. In the basement terrain, the physicochemical analysis, as reported in Adebayo, that's our work, my graduate student in 2014, 2015, and another one by Olagunju, 2017, show that the contaminant in the waste can leach into available water bodies, that is surface and groundwater, and also have adverse effects on the environmental health of humans and animals. In these studies, groundwater pollution were observed in the vicinity of the dump site. Provision of pipe-borne water by the public water works should be mandatory and planned for, especially in areas where dump sites are to be sited or already existing. This, among other reasons, can be advanced, advocated for, and demanded by the people living in areas near such dump sites. Many states in Nigeria have valuable minerals which can be mined in commercial quantity. Following from our studies, among others, as reported in ARIYIBI et al. 2011, ARIYIBI et al. 2011b, Adegoke et al. 2021, Adebayo 2018, there have been an upsurge in mining activities in many areas of Osun State. However, many of these mining sites are operated by illegal artisan miners who deploys manpower with less capital to carry out their activities. Oftentimes, these activities involve unscientific guesswork with random or indiscriminate pitting with associated pollution of water bodies. Environmental and land degradation accompanied by communal conflict, as is the case in part of Ifewara, Ilesha areas in Osun State. Much greater communal conflicts are reported in Zamfara, Plateau, Niger, Kogi, Nasarawa, and so on. However, recent mineral area survey and mapping exercise carried out by the Nigerian Geological Survey Agency and the Federal Ministry of Solid Minerals in partnership with the subnational government will likely address these issues following standard procedures and practice on mining rules and regulation activities by registered and licensed miners. The regional geologic structure over Nigeria and part of West Africa are shown by some of our results in ARIYIBI et al. 2003, ARIYIBI et al. 2004, EMMANUEL et al. 2005, 2006, and Industrial et al. 2020. They have provided information which must be considered before the planning and construction of critical infrastructure such as dams, roads, bridges, nuclear power stations, high-rise buildings, and so on. The deep oceanic fracture zones, including the Chain, Chakot, Romanch, and St. Paul, are known to extend into the lithosphere in part of West Africa, Nigeria inclusive. Likewise, the Ifewara Fault and the predominantly north-south lineament identified over the Togo-Benin Nigerian shield are worthy of consideration. Such will help to mitigate against possible damage which may arise from tremors as the African plate becomes increasingly unstable due to the active Cameroon volcanic line and the East African Rift System, among others. Mr. Vice Chancellor, sir. The sun has extremely important influence on our planet as it is the main driver of weather, ocean current, season, and climate, and makes plant life possible through photosynthesis. Can we just imagine the life on Earth without the sun? The Earth without the sun. Additionally, the space weather conditions driven by the sun via the solar wind has a strong impact on the ionosphere. The ionosphere is very important because it reflects and modifies radio waves used for communication and navigation. The study of ionospheric conditions over Nigeria and part of Africa during different geomagnetic activities events near EEJ were reported in ARIYIBI et al. 2003, ARIYIBI et al. 2013, Aketufede 2016, Jimo 2016, Olatubosu 2015, 2019, 2022, Olabode ARIYIBI 2020, and so on. These are very valid contributions on the subject matter from low latitude Africa and were published in reputable journals. Mr. Vice Chancellor, I wish to state that this output from ESPRL has provided valuable data used to improve the ARI model, which is adaptable to low latitude ionosphere in part of Africa, which are readily useful in navigation and communication system over the region. The ESPRL group is still very vibrant and with adequate funding for the acquisition of relevant equipment can provide expert services that can be financially supportive to the university. Acquisition of relevant equipment including high density MT electrometer, speedy groundwater detector, pipeline leakage detector, EM probe, digital ionosone, speed magnetometer, and so on, will enable members of the group to make positive contribution in this regard. Mr. Vice Chancellor, sir, our university, through the Department of Physics and Engineering Physics, is an active player in the international space research community. This was recognized with the siting of African Regional Center for Space Science and Technology Education in English by the United Nations Office of Outer Space in 1998. The center was hosted naturally by the Physics and Engineering Physics Department, where it actually belongs. As former head of department 2019 to 2022, and working with colleagues, we developed and got Senate approval for relevant curriculum for courses in astrophysics, space physics, stellar physics, geomagnetism, and so on at our undergraduate level, with a view to producing knowledgeable manpower in this area for our overall national growth and development. We must note that no nation develops technologically beyond its space program. Mr. Vice Chancellor, sir, appreciation and acknowledgement. I wish to acknowledge the university for providing me the opportunity to pursue and fulfill my academic dreams from 1995 to the present time. I still look forward to receive more of such support for the active years ahead. All members of my department and faculty have been very supportive and of great assistance in my sojourn in the last 3 decades. I wish to mention my HOD, Professor M. Awolowo, and then my Dean, Professor Adeshino. I'm very grateful for your support. A lot of appreciation to our donors. The working tools, equipment needed for our research were generously provided by Volkswagen of Germany, Boston College, USA, in partnership with Absalam International Center for Theoretical Physics, Trieste, Italy. The university, through the needs assessment, also provided us with a proton precision magnetometer for our lab. The establishment of the ESPRL group was encouraged and supported by Emeritus Professor E. Balogun, Professor O. Odudun, late Professor G.C. Oyedem, Professor J.B. Arubai, Professor M. Eleruja, Professor M. Awoyemi, Professor O. Akinwumi, Professor M. Adegoke, Professor J. Ojo, Professor J. O. Jegede, Professor Mr. M. O. Afolabi, and indeed the entire members of the department. The research group also benefited immensely from the objective academic criticism and vital contributions of many senior colleagues, including Professor B. Diako, Professor M. Olorunfemi, both of Geology Department, Professor S. Obion, a good friend of mine from Political Science Department, Professor E.P. Akinola, Maths Department, Professor L.A. Sumonu of Lautech, and Professor E. Ayolabi, Mountaintop University, and also from Unilag, and many others. And I want to especially also mention, for recognition and appreciation, the interventionist and guidance of Professor Bidiako that ensured the success of my academic career. I want to believe it's online and actually watching this program. As head of the ESPRL, I wish to formally appreciate the contribution of many of my former and present graduate and undergraduate students. There are many of them, very hardworking students, who have worked with the group to achieve results. After completing their training, many of these former students are currently employed as academics in Nigerian institutions and universities, while others are in Canada, USA, Europe, and Asia, making positive contribution in the field of art and space research. My gratitude to my late dad, Pastor Samuel ARIYIBI. He was an inspiration to me right from childhood. The void left by him since 2002 at age 74 have been very difficult to fill in my life. He believed so much in me and was always there to encourage and support me. My appreciation also to my mother, Alhaja Salimot ARIYIBI, who was my first teacher, who, despite her limited education, taught me good writing and good conduct. They are both precious gifts of God to me, as they jointly ensured I have good and balanced upbringing with a positive view of life. My siblings, Pastor Ola, I want to believe he's there. That's my immediate brother. I'm light complexion, but he's dark. He's there. Stand up for recognition. He's there. And then the other ones are online. That's Pastor Yemisi Orekoya, Dikines Jumoke Adebinkwe, Mr. Ibrahim Bello, and a late brother, Mr. Taju Bello, together with my extended ARIYIBI Akimi family, are all there to support me always. The Obawole family of Ile-Ife, who are my in-laws, are a special gift of God to bless my life. So I'm from Ife, the source also. A special gift of God to bless my life. Worthy of mention is my mother-in-law, Pastor Mrs. Aderonke Obawole. I'm sure she's online watching the program. I also want to remember my uncles, Mr. Olashobande of SPDC, Shell Petroleum. He has retired from there, representing all the Oshobandes. Chief Ade Saab, the Taishe of Ikotuegbe. I want to believe he's also online watching, representing all the Sulaimons. And then Alhaji Mujib Abioye. I want to believe he's also online, watching the program also. These are family members, and they are very supportive, and also serve as inspiration for my success in life. And particularly, I also want to thank the inaugural committee chairman and the member of the team. I want to thank Professor O. Akiume. Thank you very much for your assistance to ensure that this program actually is successful. My help coming from the Lord, which made heaven, in this case space, and earth. Psalm 121:2. Spiritual guidance and support from my father in the Lord, Bishop David Oyedeko of Living Faith Church, worldwide is greatly acknowledged. I want to believe members of Winners are here. All former pastors, and indeed the present pastor, Abraham Olatuji of LFC Lagiri. I want to believe he's around also. You are well done, sir. You are welcome, sir. That's my pastor, Pastor Latunji Abraham. I provided spiritual backing, which is helpful in my academic journey thus far. The Deacons Assembly, the Elders Council, and the entire church members are acknowledged individually and collectively. I also wish to appreciate members of the Gideons International in Nigeria, if a central camp. We are together on the field. Babade Yeni, you are welcome, sir. Thank you very much for your support always. And my president, the current president, I was the former president, we have the current president here, for their spiritual encouragement at all times. My greatest appreciation to my better half, my pillar of support, my closest ally, friend and darling wife, Deaconess Temilade Abidemi ARIYIBI. My gratitude to you for your understanding, tolerance, and comfort at all times. Our children, they are beside her. Akinwale, Akintayo, Oluwafunmilola, and Temitope. You shall all fulfill destiny in Jesus' name. Amen. Thanks for listening.
This certificate of presentation of inaugural lecture certifies that EMMANUEL ABIODUN, a professor of health space physics in the Department of Physics, Faculty of Science, Obafemi, Awolowo University, Ile-Ife, Nigeria, delivered the 386th inaugural lecture titled Exploring Health and Space for the Benefit of Mankind on September 10, 2024. Congratulations.